Alright, so here's your video on solving equations for a specified variable. We're going to talk about formulas and also just functions. So we've got a couple of vocabulary words, formulas, or a formula, and functions. Okay, so a formula is an equation that involves two or more variables. So let me give you a formula. Let's just say A is equal to 1/2 BH. So this would be considered a formula, right? Because it involves two or more variables. There's two or more. Okay, so we have two or more variables. That's a formula. Now, if I said that the area is a function of the base and the height, okay, times a half or divided by 2, then I'm saying that the area is determined by these other variables. Okay, I'm saying that these other variables determine the area. So when I say that area is a function of, kind of means it's a result of. Area is a function of the base and the height, right? If you adjust base and height, you're going to end up adjusting the area. Okay, so quick little rundown on the two vocabulary words we need to understand for this. So I'm going to start with one example, and we're going to solve for a specified variable. In other words, they're going to have two or more variables, but in fact we're going to have lots of variables. In fact, that's all we're going to have is variables. These are S's. I put a little tail on the S to distinguish it from a 5. So those are S's. So we have M is equal to S plus S times PH. SPH. Okay? Now, in this particular section, we're going to take a look at solving for a specified variable when we have a formula or some kind of equation. So it's going to have to tell us for what variable we should solve. Okay? So here's my information that I need. I have the formula, and then I have the variable for which we're going to solve. So we're going to get S alone. Now here's the problem. We know that these are not like terms. They're not like terms. So I'm going to put not like terms. Well, we know what like terms are. Like terms are things that we can add together and put in one place. Well, the S and the SPH, those are not like terms. So how am I ever going to get S all alone if I can't get them in the S's in one spot? Well, we're going to do a little trick on this one where we're going to rewrite the problem. Okay, if I have my variable that I need to get alone, right, all in one, alone, and I have two or more places where the variable is, I'm not going to be able to add them together if they're not like terms. So what I'm going to do is kind of go the backwards way. In a backwards way. I'm going to divide. I'm going to factor out. Notice I have S in both terms. I'm going to factor out that S. Now, convince yourself that that does go back. Does this times this and this times this go back to this? Of course it does. Now, look what I've done. I've actually gotten S in one location. They want me to solve for S, so I've gotten S in one spot. Now, that's most of the battle right there. Most of the battle. So now what am I going to do to get S alone? I'm going to divide by what's being multiplied times the S. So I'm going to divide by what's being multiplied. They divide, multiply, they undo each other, right? This is the division property of equality. So then we get this. We get S on the right, and we get this weirdo, funky looking thing here on the left, but we don't care how weird and funky the left-hand side is because we've got an S alone. And that's exactly what they asked us to do. Solve that for S. So now we can say that S is a function of, and then all of that, M divided by 1 plus pH. In other words, the S is alone, so that's when we say it's a function of. Okay? All right, let's take a look at another one. All right, this one's going to look familiar. We have 2L plus 2W, and that's equal to P. Now, what's that remind you of? That's perimeter, right? Length and width. 2 lengths and 2 widths is the perimeter. But then remember that they have to tell us. There's so many variables there. I don't know the one that they want me to get alone, so I have to look for it, and it always is going to tell me which variable to get alone. So solve it for W. Now, is W, the first question I'm asking myself is W in one spot? Is it already in one spot, in one location? Yes, W is right here. So really that just means I'm going to kind of strip away at the W. And here's what you can think that this is like. You can just think of this as 2 times x plus something here that you don't really need, or that you don't want it there, and then you could do that. Let's just pretend. Let's just think, okay, here's my thing right here, is my variable, and I'm going to solve that for x, and everything else is just stuff around it. So what would I do in this problem here? The first thing I would do would be minus 8. So that's exactly what I'm going to do. So my process would be to minus 8 from both sides, right? So guess what I'm going to do with this green one? I'm going to minus 2L from both sides. So let me put it back on here. Okay, and let's go ahead and subtract the 2L from both sides, meaning both sides of the equal. So we have P minus 2L is equal to 2W. Okay, now what are we going to do? We're trying to get the W alone. So what are we going to do? We're going to divide by 2. Divide by 2. And W is equal to this weirdo, funky looking thing. Right? So we say that W is a function of P minus 2L over 2. Now, can I cancel these two P's? Say no. I cannot cancel those two P's. Why? Because this P is available for canceling, but this P up here is connected with a minus to the next guy, and so it's not available. It's a term and not a factor. So no, we cannot cancel the two 2's. So there's your answer right there. Okay, one more. And let's go with this, number 3. This is a familiar one, right? Even from your science classes. This is the Fahrenheit formula that relates Fahrenheit and Celsius temperatures. And so what we want to do on this one, we have to look for what they want. They want it to be solved for C, meaning get C alone. So what am I going to do? Well, this is easy. I'm going to go minus 32, minus 32. So we have F minus 32 is equal to 9/5, 9/5 C. Now, this might be a little different, but I don't want to divide by 9/5. Here's what I'm going to do. I'm going to multiply by 5/9. You understand that that's going to do the same thing. And the reason I'm going to do that is this. I would rather have the times 5/9 on the left side. So watch what's going to happen here. So that gives me C on the right, because the 9/5 times 5/9, those are multiplicative inverses, so they're going to create a 1. Okay, so then here's what I have on the left. 5/9 and then F minus 32 in parentheses, right? Because this 5/9 is waiting to be multiplied. So there's my function. C is a function of, it's a result of 5/9 times the quantity F minus 32. All right, thanks for listening.